Today we are going to be discussing parallel circuits. Parallel circuits are circuits that have branches, and by that I mean different paths for the current to flow. It doesn't have to go in one specific direction. It can break off into different paths. And what that looks like is, say here we have our battery, and you can have a resistor here, and a resistor here, and a resistor here. Okay, so that means the current can come down here, and some of it can go this way, some of it can go this way, some of it can go this way, some of it can even go this way. It's different paths for the current to flow. We're going to look at this circuit. We have a 12-volt battery and three 2-ohm resistors in parallel. We want to find the current. Okay? Now, this is nowhere near the series circuit. It's a little bit harder, but not that much. On parallel circuits, it is 1 over the total resistance is equal to the sum of 1 over each resistor. Okay, so that's 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3. So, let's find our total resistance. So, 1 over the total resistance is equal to 1 over 2 plus 1 over 2 plus 1 over 2. The easiest way to do this is to get rid of the fraction. Put it in decimal. So this is 0.5 plus 0.5 plus 0.5, which is 1 over resistance total is equal to 1.5. Now we need to find resistance. That's just a flip. So that means resistance total is equal to 1 over 1.5, which is 0.67. Okay, so that gives us our resistance total is 0.67 ohms. Okay. Well, back to our 12-volt battery. We know this is equivalent to total resistance of 0.67. Well, now we want current. V equals IR total. So this is 12 is equal to I times 0.67. So I is equal to 12 divided by 0.67, which is 17.9 amps. So the current in this circuit is 17.9 amps. Let's look at this current. We have, again, a 12-volt battery. We have a 2-ohm resistor, a 3-ohm resistor, and a 4-ohm resistor all in parallel. But we don't know the current. Let's try and find the current. We know 1 over total resistance is equal to 1 over 2 plus 1 over 3 plus 1 over 4. Get rid of the fraction. So this is 0.5 plus 0.3 plus 0.25, which is 1.05. So that means resistance total is equal to 1 divided by 1.05, which is 0.93. So that means our voltage is equal to I, resistance total, which is 12 is equal to I times 0.93. So I is equal to 12 divided by 0.93, which is 12.9 amps. So if we look at this, we know the current goes through, and some of it goes through the 2 ohm, some of it goes through the 3 ohm, and some of it will go through the 4 ohm. But how much current goes through each one? The one thing that is constant in parallel circuits is that the voltage across each one of these is going to be 12 volts. So, going back to our problem, what is the current through the 2 ohm resistor? We know V equals IR, our go-to problem. So, we know 12 is equal to I times 2 ohms. So that means I is equal to 12 divided by 2, which is 6 amps. Well, let's look at our 3 ohm resistor. So for the 3 ohm, what do we know? We know 12 is equal to I times 3. So I is equal to 12 divided by 3, which is 4 amps. And then our 4 ohm resistor, we know 12 is equal to I times 4. So that means current is equal to 12 divided by 4, which is 3 amps. Okay, let's look at something. If you take this current plus, and that's in through the 2, and then through the 3, and then finally through the last one, and add them together, we should get something very close to if it was one solid resistor. So we need to find out if we get something close to 12.9. So we have 6 plus 4, which is 10, plus 3, so that's 13 amps total. So 13 amps is very close to 12.9. Rounding, it's the same. So that shows us that you have 13 amps total going through each. When you add the branches up, it equals 13. So, in parallel circuits, you know current in the entire thing has to be equal to the current in each branch. So for us, we only had 3 branches, and when you add those 3 branches together, we got 13 amps, which is what we got when we found the total current going through when you had the resistors, the equivalent resistance. Let's try it again with another one, see if it really works. So we now have a 24 volt battery, and we have a total of 4 resistors. A 2 ohm, a 4 ohm, a 2 ohm, and a 5 ohm. The first thing we have to do is find the equivalent resistance. So the total resistance of that circuit. So 1 over total resistance is equal to 1 over 2 plus 1 over 4 plus 1 over 2 plus 1 over 5. Get rid of the fractions. 0.5 plus 0.25 plus 0.5 plus 0.2. So that is 1.45. So 1 over total resistance is equal to 1.45. So that means total resistance is equal to 1 over 1.45, which is 0.7. ohms. So we know the total resistance of that circuit is 0.7 ohms. So what is the total current flowing through that circuit? So V equals IR. 24 is equal to I times 0.7. So I is equal to 24 divided by 0.7, which is 34.3 amps. So now let's see for each branch if that works for this one too. So let's do the 2. So for the 2 ohms, we know 24 volts is going to be the voltage, current times 2. So that means current is equal to 24 divided by 2, which is 12 amps. Okay. For the 4 ohm resistor, we got 24 is equal to I times 4. So I is equal to 24 divided by 4, which is 6 amps. Another 2 ohm resistor, same thing, we're going to get 12 amps. And then for our 5 ohm resistor, we know 24 is equal to I times 5. So current is equal to 24 divided by 5, which is 4.8 amps. So if we add those together to get the total resistance, or total current, that's 12 plus 6 plus 12 plus 4.8, which is 34.8 amps. And originally we got 34.3. That is close enough. It has to deal with not being perfect due to the rounding errors. So if we say this, we know now for parallel circuit, the equivalent resistance, 1 over resistance total, is equal to the sum of all the resistors. So n equals 1 to infinity, or 1 to whatever number of resistors we have. And we know that in the current total has to be equal to the sum of all the currents in the branches. Let's do one more just to verify. Look at this one. This one's a little different. We don't know the voltage of the system, but we know the total current is equal to 2 amps. We know the current in the 4 ohm resistor is 0.5 amps. We know we have resistor 1, which is the 4 ohms. We know we have a resistor 2, which is a 2 ohm. And we have a resistor 3 that we don't know what it is. And we don't know what voltage is. But we need to find those. They're easy to find. Let's look at the first thing to look at. We are going to look at what's going on with that 4 ohm resistor. So we're going to look at this. We know that V equals IR. We have I. We have R. So we can find the voltage of that circuit. So we know V is equal to IR. We know it in the 4 ohm resistor. So we know in the 4 ohm resistor it's 0.5 times, and we know the 4 ohm resistor is 4 ohms. So 0.5 times 4 ohms is 2 volts. So we now know the voltage for that circuit. It is 2 volts. So V equals 2 volts. Okay, so now we can find total resistance of that circuit. Okay, we know V equals I R total. And if we use the total current in the circuit, we know 2 is equal to 2 amps times resistance total. So that means resistance total has to equal 2 divided by 2, which is 1 ohm. Okay, so now we know that. Okay, I don't really want to go into the 1 over total resistance equals 1 over 4 plus 1 over 2 plus 1 over 3. I don't want to deal with that part. So let's just look at what we've got. We know current. We know voltage. So let's look at the 2 ohm resistor. What's the current flowing through it? Well, we know voltage is 2. We know current is what we're trying to find. And we know the resistance is 2. So the current for the 2 ohm resistor has to be 2 divided by 2, which is 1 amp. Okay, so what else do we know? Okay, we know V equals I R. We know our current is 2 amps in the entire circuit. We know the voltage is 2. So V equals IR gives us resistance has to be 1. So to double check ourselves, we know 1 over RT, which is 1 over 1, is 1. And that has to equal 1 over the first resistor, which is 4, well, plus 1 over the second resistor, which is 2, plus 1 over the third resistor, which is 4. If that statement here is correct, then our circuit is correct. So we know 1 over 1 is 1. Let's check and see. 1 over 4 is 0.25. Plus 1 half is 0.5. Plus 1 over 4 is 0.25. 0.25 plus 0.25 is a half. So that's 0.5 plus 0.5, which is 1. So that is a true statement. So our circuit is correct. So with that being said, parallel circuits use the following formulas. V equals I R. I total is equal to the sum of the current through all the branches. And 1 over resistance total is equal to the sum of 1 over each resistor for each branch. Okay? And that is parallel circuits.